Hi, I'm Anchorman Ross Aronson, here to bring you the latest updates on physics and football. My two co-hosts, Megan and Molly, are going to commentate on what is going on during these football clips. Thanks to Abby for being the camera woman. I hope you all enjoy learning about physics. Alright now, I'm going to turn this over to Megan and Molly.
Number 87 is running at a fast speed and keeps going until there is an unbalanced force that acts upon him. In this case, the unbalanced force is the defender that tackled number 87, number 20. This is an example of Newton's first law. Newton's first law is an object in motion will stay in motion until acted upon by an unbalanced force. Number 87 is trying to resist a change in motion while he is running. This is an example of inertia. Inertia is the tendency of objects to either stay in the same place or to continue moving in a straight line at a constant speed. The force of the defender was enough to stop number 87 and all his inertia, which caused him to fall down. Wow, co-host Megan, wasn't that a really hard hit?
It was so hard, I can't even believe my eyes.
That must have hurt so bad. Poor number 87.
I feel so bad for him.
But it's all because of physics.
Physics. Newton's second law tells us that the more mass something has, the less acceleration, and the more force something has, the more acceleration. In this video, number 44, Ben Tate, is able to escape the Tennessee Titans defenders because he has a significantly smaller mass than his opponents do. His smaller mass allows him to outrun his opponents. Since his defenders have more mass than he does, it is harder for them to accelerate and catch up to Tate.
Wow, Ben Tate is really fast, huh, Megan?
Yeah, it's just like, I wish I could be that fast.
It's because he's really small, right?
I'm sure that's why.
Physics just makes so much sense. Newton's third law tells us that forces come in pairs, equal and opposite. As soon as the ball is lateral to the running back, he applies a frontward force, but then is soon met with an unbalanced force that causes him to fall back and fumble the football. Just as the defender applied a tackling force to the running back exerted the same amount of force on the defender, an example of Newton's third law. High five, Megan! Wow, that was just an example of Newton's third law too!
Really?
Yeah, because our hands were equal and opposite, acting on each other. Just like those big, hefty football players.
That's so cool.
Yeah, but I wouldn't have wanted to been hit by those big guys.
Me either. Friction is a contact force between a moving object and the surface it moves on. Friction is always in the direction opposite of motion. An object has to be in motion to have friction. As you can see in this video of me playing football, I struggle to play in my socks, but succeed when I play in my cleats. This is because of the coefficient of friction. The coefficient of friction measures the stickiness of two surfaces relative to each other. My cleats had a higher coefficient of friction, which is what I need to play football successfully because it allows me to have a greater grip with the ground as opposed to my lousy socks.
Well, folks, that is enough for now. We have learned Newton's 3 laws of motion, key physics terms, and how they relate to the great game of football.